And now I'm very happy to announce the keynote. The Internet is Your Application Blueprint by Lukas Smith and Henri Bergius. Please welcome those two guys.
Thanks. Yeah, so hello everybody. I'm Henri Bergius, originally from Finland, now living in Berlin. Background in the Midgard community.
Hi, I'm Lukas Smith, living in Switzerland, originally from Berlin, working for a company called Leap, and quite involved in Symfony 2 and PHP stuff in general.
Okay, so yeah, we're talking about the internet, the application blueprint that you should follow. The sad fact is, if you look at your current software, everything you've built, most likely they are monoliths. The architectural diagram will look like this. You have underneath a database, file system, some things like that. Then you have a framework. It might be just PHP, or maybe you're using Rails or Symfony or whatever. And then you have the application there. And this application consists of things that spit up machine-readable stuff, HTML, and even executable JavaScript. But anyhow, all of it is in this one tall silo. This kind of monolith might remind you of something. Last time we saw these monoliths, there was also a computer that kind of misbehaved. So you might want to reconsider. Of course, the other thing about a monolith is that it's a great place for hiding spaghetti code. It might be your code, it might be somebody else's code. Maybe it's something you got as a dependency. Our software consists of so much spaghetti that some people actually made it a religion, as you can see here. So let's try to clean our act a bit, because otherwise this monolithic, big, unwieldy code base will hold you hostage. You need to go to a new direction. Maybe your business plan changes, or maybe there's a new requirement, new business partner you need to integrate with, new feature you'd like to do. And suddenly, this silo makes it very difficult. The other thing is, technologies come and go. They're a bit like fashion, you know. Now it's the long skirts or whatever, stripes or squares. The screenshots you see here about various technologies sucking, I think are mostly a testament to the fact that if some particular technology becomes reasonable enough to be used or widely enough used, there will be rants about it. So essentially the story is probably, if you want to use some technology and nobody's saying that it sucks, then nobody's using it. And you know, technologies fail. You might remember this guy, the whale. It's not been so visible lately, mainly because Twitter started their story building everything on Rails, which was a good way to get started, but then obviously it didn't scale to the millions and millions of users they have now. So they had to go and migrate things to different PCs. Now, we might have seen a lot less fail whale if they had thought about decoupling things right from the beginning.
Right. So the internet is built on top of protocols, and that is very, very significant because based on this architecture, the internet is scalable. It embraces failure. So failure is not something that is tried to be avoided at all costs, but it's something that if it happens, things keep moving, things keep going on. You don't just flat out fail and nothing happens anymore. You still see one side even if another one goes down, right? It also delegates responsibility. It's not a central authority that knows how to do everything and knows how to display everything and knows how to process everything. So it delegates responsibility, and thereby the different clients, the actors within the internet that actually make up the internet, can all do their part in bringing content and useful features. And it's language agnostic, so it's not everything is written in PHP. Okay, most is written in PHP, but some of it is written in Java and Ruby and so on and so forth, and that's fine, and it works and it plays together. Now, what it all really just boils down to, all the things that I just mentioned, is it's decoupled. So things are not tightly coupled together, enabling all these things that I just mentioned before. And now let's look at how that could affect the way that you're building an application. So later we'll look at more of a service approach to this, but even inside your applications, while you don't necessarily have to have HTTP or some other protocol for communicating between, inside your applications you have a concept called interfaces. And interfaces are, in a sense, programming level protocols. However, we haven't really been doing that a lot with PHP specifically. There's actually a group called the Framework Interoperability Group. They went through a couple names or non-official names before, but they basically brought the PSR0 convention, which is basically a convention defining how you're supposed to structure your files on disk and how that maps then to autoloading. But since then, they have the PSR0, and then they have PSR1 and 2. And PSR1 and 2 are basically about coding style. And that's it so far. So now the list is basically talking about how to interpret white space. Like, is it an empty line if I still have some spaces in there or not, rather than really tackling important stuff like interfaces. So right now, I think there are about 20 emails per day, and really they just talk about coding style. And I think it's valid. Like I'm fine that there's a PSR1, PSR2 standard, but I would much rather like to see us work towards standardizing HTTP interfaces, like what Symfony 2 and Zen Framework offer, or HTTP clients, caching, and logging, and things like that, because if we would have such interfaces, people could create libraries that implement these interfaces, and your application would no longer be bound to a specific implementation of that. You could just swap that out, and everything would keep working. Again, keeping with the idea that I can use different browsers to browse the internet. If I don't like how Firefox works, I can switch to Chrome. And the same thing we're currently not making possible in our applications, because we're binding our applications to one specific implementation.
Yeah, so one way to look at it is, obviously interfaces are important inside a particular piece of software. But then you can also go a bit further. You can think about services that particular pieces of your applications supply. So that takes us back to service-oriented architecture. You might remember all the hype about it a few years back, but there's actually some pretty good points there behind all that hype. Most of the stuff that we used to call service-oriented architecture, you would now call cloud, or you used to call Ajax or whatever. So let's see what actually is there. So if you think about a typical web application, there's various different services that are always there. There's some sort of account service which handles the logins, the authorization, who is permitted to do what. Then there is the data storage and retrieval service. I call it API here. And then there's the actual web frontend where stuff happens. Now, most web applications do all of these as one big monolithic blob. That's because that's the way frameworks and documentation and everything guides us to do it. But really, these things are separate, and there's no particular reason why they should run in the same process or the same server, or in any case, be bound together that tightly. When we were researching for this keynote, I ran into a couple of very good blog posts about like how people think about building websites in the modern era. Not just trying to do everything as one application, but instead taking different pieces of services on the internet and then binding your application to those. And if necessary, then building your own stuff alongside. So if you need something that isn't available, make it a separate service. And one of them actually, these guys were showing a very interesting tool called Prose, where they decoupled the act of web editing from the actual web server completely. The content is stored in a Git repository. You log into your GitHub account, and you get a list of whatever content you have on your website. And then you just go and edit it. And this way, the whole act of editing your stuff has nothing to do with the way it's published. You could easily make this send emails or whatever. You get versioning, all that stuff comes there. So this is a pretty nice way of thinking about authoring. Now, if you think about service-oriented architecture, big words, complicated ideas, but the fact is, most of you are actually already using service-oriented, at least parts of it. One good example are feeds. If you're running a blog or a news website, you are most likely providing a feed out of it. There are also websites like Planet PHP here, which actually are completely built around the idea of feeds. They grab blogs of, I would imagine, quite a lot of people in this room, mash them all together, and provide one unified news feed. Another one, nowadays, website login is often looking more like a Formula One car because you have all these different logos. Sign in with Google, Facebook, Twitter, whatever. But that's a good example of delegating the act of authenticating a user to an external service. How many of you have done, let's say, Facebook authentication in a web app? Maybe 1/3. Yeah, I'm not asking about the other services. It just shows that this is actual service-oriented stuff you're already doing. Commenting is another one. All of us have written PHP scripts or CGI scripts in the good old times, which would handle some sort of user comments. And then, of course, you always get to the fun part of dealing with the comment spammers and all that. There are pretty good services out there. You can use the Facebook comments, you can use Discuss, and more blogs and other web services are actually switching to using comments as a service instead of using their own code for that. Because a centralized service can provide a nicer user experience, and secondly, they are a lot better capable to handle comment spam. Just because, they deal with the same spammers on a lot of websites. Embedding is another one. When I started doing websites, when I started doing websites, we didn't have video on the web at all. But let's say 10, 15 years ago, you would have to go to Real Networks or some other company and buy this big, expensive media streaming service just to be able to have video on your website or slides or whatever. Nowadays, all of us are just embedding the stuff from YouTube, Vimeo, whatever. Analytics is another one. Instead of installing your own analysis tools, you're probably using Google Analytics, Web Trends, something like that. All of these are services that you use. Search, again. We all used to install these custom search engines, but nowadays, Google does a pretty good job of searching, so just why not use their search as a service? Then you get to a bit more interesting things. You can do you can also make your website be a service. When you're publishing HTML pages, you can use semantic markups. You can use microformats, microdata, or RDFA to explain the things you're showing on a web page. And this is where actually your website becomes a service to other systems, like in this case, a Google search. So you can look at the first result there. It's not an ad. It's just a regular search result, just like the others. The reason why it looks different is because they are using semantic markup to tell, OK, this is a recipe. Here are the ratings for it. Here's a picture. And then the search engine shows it. So in this case, it's really your website that is the service, and Google that is the client to that service. And you get better results. I've heard reports of getting like 10, 20% increase just because of doing this. And then when you have semantic markup, you can actually do other cool stuff, like my tool, Create.js, that we are going to be talking about more in the next session we have. This one here uses the same semantic markup that Google uses. You add this JavaScript tool to your web page, and it makes all of your page or the relevant parts of your page editable. You just edit it where it's shown. You click Save. It goes to your server. This is something that now an increasing amount of different content management systems is doing. And you can do the same for your own application. So while you're helping Google understand your content, you can also help your end users to produce the data. And of course, there's all these different pieces of infrastructure. This is a bit more a point where it really depends on what you need and what you can do. But more and more parts of what you're running, you can actually get from somebody else. You can have Microsoft host your message queue, or you can have Redis host your database. And you can really mix and match there. There are lots and lots of specialized service providers there. You don't have to do email sending on your own server or SMS or whatever. You can get all of these different building blocks out of the internet. Of course, most of them come with some sort of subscription price. So in the end, it really depends. Maybe it might be cheaper to do it on your own, maybe not.
Right. Of course, there are some issues with that. But actually, I want to add sort of more of a personal experience with exactly that. So in the company I work for, Leap, we had this very, very ancient CMS. We've now migrated our homepage to something newer, but the content authoring we didn't migrate in that process. So right now you still have to use the old ancient CMS if you want to write a blog post. And that really became a major annoyance for people. And since we did want to encourage all the teams to blog about the projects that they've done, Rego, one of the founders, actually, he just created a GitHub project, and he's now just has a cron job monitoring anything that gets added to that GitHub project. And all you have to do to add a new blog post is to put a markdown file into that Git repository, and automatically it will be added to the blog. So we solved two things there. So now we don't need to set up accounts for everybody on the CMS anymore, because they already have a GitHub account, and they have the permissions through GitHub. So we solved authentication that way, and the authoring, everybody can use whatever editor they prefer, right? So it's a very, very simple solution to something that was a major annoyance, right? And again, this is all using free services. But anyway, enough of the happy talk. There are obviously some problems going into the cloud or whatever, right? So this is a blog post, talks about some of the problems. So obviously, when you get started, service-oriented architectures can take longer to get started. Like just getting all these pieces together, setting them up, getting your account set up, connecting it all together can take longer. At the same time, if you just think about like I want to create a new website, then obviously you could download something like Drupal and get started. And if you know Drupal well, then probably you're going to be very quick in creating a new website. If not, then maybe something simpler, just using Jekyll and Discuss might even get you there faster, and you would be using separate services that you can scale separately and advance separately in terms of features. Now, another, and I think that's actually one of the biggest concerns that I personally have, is that you will run into different APIs. They might not be compatible with each other. And as you're building your own services, and especially initially, you're going to be changing lots of things, and then your APIs are going to get out of date. API versioning is sort of an iffy topic. It can get quite annoying at some point to maintain older APIs, and migrating everything at once, if it's all one application, might be easier in terms of just organizational aspects. Another thing is that to benefit from all these services architecture, and if you're building your own services, obviously what you need to do is then also to separate them on different servers if you want to be able to scale them separately. However, if you have just a very small project, you probably don't want to set up 3 different virtual machines for all the different services. So that's another overhead to consider when you're doing that. Then again, there are lots of providers that are making it quite easy to set up separate virtual machines and scale them without having to invest more money than with a single server that has the same resources in terms of raw processing power. And that's another big topic here. You're sort of on your own, even though you can't solve everything on your own. So you're going to deal with things that are maybe less supported or less well known, because most people are still doing some framework as their architecture. Not many people are thinking in terms of using all these services. And so, yeah, there might be more work for you to do in terms of the learning experience in setting this up. At the same time, I think it's a trend that will continue, and therefore I think more people will become skilled in these kinds of setups. And there's obviously lots more things to consider, like if I have a separate service for the authentication, separate service for my comments, and another service doing something else, how do I write a query that spans all these 3 different services, right? With SQL, in my own database, it's quite easy to do. There are not any standards for doing that quite yet, and then there will be performance considerations. There are other aspects as well, just legal things, terms of service, like if the service is down, it might mean that you're losing a lot of business, but the contract that you're being offered doesn't care about that. There might be legal problems, like is Discuss even legal in Germany? Because you're storing user data outside of Germany, outside of the jurisdiction of Germany, and that doesn't quite fly well with the German privacy laws. There may be missing features, and again, you might find that these are very, very important, but the provider doesn't care. So what do you have to do then? You still have to create your own service, integrate that with the other service, and so that creates some overheads and things like that. I still think that thinking in terms of service-oriented architecture and reusing these services, like reusing Flickr for image upload and things like that, will save you a lot of time when you get going, and can also help you scale. But there are definitely these problems, and these are the things that you need to consider when you're making these decisions, and you also need to factor that in when you're setting up your project.
Yeah, so once you overstep all those hurdles, the next big question is, how do you actually manage this kind of architecture? How do you build these things? And there's a couple of good techniques here. One of them is edge side includes. So if you've been running Varnish or something, you might be already familiar. So if you look at the Yahoo page, for instance, you can see there's a lot of content there. And you could easily think of this as different bits and pieces coming from different services. So something like edge side includes can actually go and talk to different parts of your infrastructure to serve a single page to the end user. So if your stock quotes or your weather information are handled by a separate service and your newsfeed by another, then with edge side includes, you can actually bring them together, present one consistent web page to the end user. and still handle caching and all that stuff efficiently. So this is a good way to kind of tie up the user experience. Then the other thing is how to deal with all these events, how to connect these services together. So there, at least my experience, message queues are highly useful. So you could do something like this. In this case, we have an ORM that sends storage events like this and this record was created or updated. We go to a message router and we look at the different things we are actually interested in. And we send them to different business processes. Maybe if you create a new user, we need to send them a welcome email. Instead of handling that directly inside our database classes, we can separate that completely out. It can run on a separate machine, maybe even be done in a different programming language. And this way you can have a lot more flexibility. The other important piece here is the business metrics. So this might be something useful. You can track every message coming through. Anything that is saved to any parts of your service infrastructure, you can at least get information. This is how many comments were created yesterday. This is how many users registered, or this many customers paid an invoice. And this can help you figure out where the scalability bottlenecks are. It can also bring you very valuable insights about how your business, how your web application is actually operating.
Yeah, I think the message queue architecture is something that is very, very useful going forward, where you really enable also your different teams within your organization to come up with different questions or challenges without having to talk to each team. So again, this metrics example is there might be one team writing or adding the new commenting, and then there's another team that is interested in the metrics. And without a message queue, these two teams have to hold meetings together and decide on APIs and things like that. If the entire organization has already agreed on how to put a message on a queue, then that's it. You don't have to have a meeting just because you want some sort of integration point. All you have to ensure is that everybody puts any relevant event into the queue, and then everybody can take out the pieces that they care about. But at any rate, so let's bring that back a little bit to the PHP world. So earlier I was talking about decoupling on the application level. And there is already something that I think will be very, very critical in that trend, and that's called Composer. It's a dependency manager. There's a website called packages.org where anybody can register their package. However, if you have your own libraries that are internal that you don't want to make public, there's actually also a sub-project of the Composer project called Sahi that allows you to set up your own package repository and still leverage Composer to define your dependencies. Now, I was also talking about interfaces. So this is an example of, or an excerpt from a Composer file. It's basically you write it down in JSON. And so this is the Jackalope package. And Jackalope implements a standardized interface, set of interfaces called PHP-CR. And there are multiple implementations of that. And so what you can do in your Composer JSON, you can say that I provide an implementation of PHP-CR. And then any application code that's written against these interfaces, the PHP-CR interfaces, all it's going to say, I'm going to require a PHP-CR implementation, right? And so as soon as anybody adds any as soon as you add Jackalope to your project, that it basically means that it has an implementation of PHP-CR. So I can have another package that says, again, I need PHP-CR to work. All it's going to state is I need a PHP-CR implementation, and by adding Jackalope, that dependency is solved. So if we start working on more interfaces for PHP, again, for HTTP clients, for caching and logging, with this approach, any package that just needs caching, all it has to say is, I need a cache implementation, and following that set of interfaces. And I need a set of log classes that implement these interfaces. So I think if we really push hard and work through the challenge of standardizing these interfaces together with Composer, we will have finally a way of expressing that in a way that actually lets us separate the dependencies and create cleaner applications. I'm working on a project called Symfony 2 CMF. There we're trying to follow these principles. So we're using PHP-CR for content storage. Again, this is a specification of just interfaces. And we've actually set up the example project where we originally used one implementation. And just by changing configuration, we can use any of the other implementations just fine. We're also using Symfony 2, obviously. Well-written framework. Same approach could be applied using ZenFrame or any other framework for that matter. We're using Henri's Create.js, which allows us to really keep the server side separate from the client side, because all we have to do on the server side is generate RDFA, and then Create.js can process that, and then Create.js sends us back a JSON that we then store in the database. But as a matter of fact, if somebody doesn't like Create.js or the UI or whatever, he can just throw that out and still use the CMF and just create a new UI using whatever they prefer, XJS, etc. And then we're also going to use Varnish for caching. One thing that we currently are missing on here is where are the other services like Flickr, Vimeo, etc. for image processing, and that's definitely something that should be covered as well. And I think that's actually something that most users nowadays expect from a CMS.
So yeah, kind of to draw some conclusions. The important lesson here is when you're building a larger piece of software, think in the terms of protocols. What parts of your software could be separate? What kind of protocols would they need for communicating with each other? In some cases, it's fine to do these as interfaces. If you're doing these two pieces in PHP and you know that from now to eternity they will be PHP, then working with interfaces is fine enough. If you know there might be different teams working with different languages, or you might want to scale things independently, then you'll want to think about some sort of wire protocol. The other thing is, even though you will need to build services, you need to build new applications, reuse all the existing infrastructure. This might mean instead of writing your own library to do authentication or logging, go to Packagist, or if you're using Node.js, to NPM, to all these different code repositories, and get a library that does it. There might be a hosted service doing the thing you need, then just go and use it. The point is not to have more code. The point is to have more functionality. So yeah, the other thing is really, when you're building our own stuff, build things as services. Don't build these monolithic blobs. It might be that you are your own services consumer, but it might also be that somebody else in your organization or some business partner needs that data. And then having an exposed, standardized service interface makes a lot of sense.
So thank you.
Yeah, thanks.